try it. Close, but yeah. So it's going to make NH4Cl and, of course, water HOH. And I'm going to do this in the gas phase. I'll do a little bit in front of you, then a whole. Yeah, I should just do it all in front of you.
Yeah.
I made a bunch of smoke and it didn't actually set the fire alarm off, so you'll be fine. So here is concentrated hydrochloric acid. I'm gonna make a little smiley face. Whoop, there's my concentrated hydrochloric acid. This is my smiley face of concentrated hydrochloric acid, and I'm gonna make 2 eyes of ammonium hydroxide. So what's happening is the ammonium hydroxide and the hydrochloric acid are reacting. And then off it goes. Yeah.
Don't become me.
You wanted me to do it in the fume hood too? You're like, it's all smoky. Okay. Oh, this is really fun too. Check this out. You don't even have to like put them down. You can just set the things next to each other.
Dang, that's cool.
Magic-y smoke. Smoke, 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 smoke. So, that's good enough. You don't like ammonia? I thought you guys liked ammonia. You're all doing your hair and stuff. Okay. Do you want me to open the door?
Yeah.
Okay. You do you just do whatever you want, buyers. Okay. Oh, it is such a nice day today. All right, so any questions about this stuff? Question? No. Well, they can, but probably not. No, you make fake smoke with glycerin. Basically, you heat up glycerin and alcohol until it boils, and then it recondenses. It looks like smoke, little droplets of smoke. So what you saw was little droplets of ammonium chloride. They make little droplets of glycerin. Okay. Apparently, I have a defective doorstop. All right, ladies and gentlemen, last question before we do some practice. Can you ever have a negative compound?
No.
No. Okay, no you can't. So the positives are going to switch, or the negatives, so you're always going to have positive, negative, positive, negative. Now if you understand this, and hopefully you do, I have some practice for you that I'd like you to work on. Please balance these 4 things. Got a synthesis for you, a single replacement, a hydrocarbon, and a double replacement. Did I not give you enough work? You need more work?
No, you're good.
Oh, because when you're chatting not about chemistry, it feels like you need more work. The ammonium?
Yeah.
Well, it's frequently used in cleaning products, and more concentrated ammonium is used in hair dye.
Yeah.
No, that's not bleach. Bleach is something different. Is it too cold for you? Is it too? All right.
When like I put an 8 here, so it'd be 10 hydrogen and then 8 oxygens. If I do for that one, do I add that one and that one?
You would add them, yep. Whatever all of them on the left equals all of them on the right.
Okay.
But keep in mind, the first thing you should do is realize that this carbon is C4. This carbon is going to have to be 4, 8, or 12. Does that make sense? Because it can't be anything but 4, 8, or 12 because C4 is C4. So it looks like most of you have the first two done. Let's go ahead and break those down. Who's got the first one? Like to volunteer their answer? Austin, what do you got?
4 and 3 for this person, and then a 3, and then a 2.
2? Okay. So let's see. 4 irons. 2 by 2 is 4 irons. 3 by 2 is 6 oxygens. 2 by 3, 6 oxygens. And it's balanced. Good job. Who's got the next one? Okay, Jack.
So yeah,
3 magnesiums? Nothing at all? Okay. Or 1.
and then 3
All right, let's take a look. 3 magnesiums, 3 magnesiums, 2 irons, 2 irons, 3 oxygens, 3 oxygens. Well done, Jack. Okay. So good job, Jack and Austin. Now the next one's tricky. Some of you are working on it. I will remind you that this C4 is the only place you're going to find carbon on the reactant side. And this C in CO2 is the only place you're going to find carbon on the product side. So this number in front here can only be 4, 8, 12, 16, or 20. Probably I'm not going to give you numbers that big, but 4, 8, 12, 16, or 20, because they have to be a multiple of 4. Do you understand why? Yeah. All right. Next, this hydrogen is 10. So that means this hydrogen has to be what? Yeah, a multiple of 5. It has to be 5, 10, 15, 20, 25. Okay, so with that information, continue your work. Yeah. Well, compare it with your neighbors. Work in parallel. Compare your work with your neighbors. And you have an answer that you like. See if they like it too. The third one's actually a little bit easier than the fourth one's a little bit easier than the third one. Are you volunteering your answer? Are we ready to see the answer?
No. Yes.
No? A few more minutes? Okay, a few more minutes. I don't know. We'll see. Emily's volunteering her answer, so she hasn't spoken this week yet. I'm sure it is. Have you compared? Okay. Okay. I'm going to let Emily answer this one. Don't be mad. You'll have plenty of opportunities in coming days. All right. So Emily, what did you put right here?
2.
A 2. Okay. And what did you put here?
13.
A 13. And what did you put here?
8.
An 8. It is a multiple of 4. What did you put here?
10.
A 10, which is also a multiple of 5. Excellent. Okay, so let's take a look. 8 carbons. 8 carbons. 20 hydrogens. 20 hydrogens. 26 oxygens. 8 by 2 is 16, and 10 by 1 is 10. 26 carbons. Well done, all of you who agreed with Daryl's answer. Okay. And the last one. Who's got the last one? Okay, Lane, what do you got?
Okay. So the Mg3PO4 stays the same.
1, okay.
And then that has a 6.
A 6, okay.
And then the Ag3PO4 is a 2.
A 2.
And the next one is a 3.
And a 3. Okay, let's take a look. 3 magnesiums. 3 magnesiums. 2 phosphates. 2 by 1, 2 phosphates. 6 silvers. 2 by 3 is 6 silvers. 6 nitrates. 3 by 2, 6 nitrates, and it's balanced. Well done, Lane. Okay, any questions about this? We're about to change gears and then call it a day. Feeling good about the balancing?
Yes.
Excellent. Okay. So we have a sim tomorrow and then busy work worksheet on Friday, all on balancing. Mole ratios are things we're going to use a lot in January. You just need to know what they are. Mole ratios are the coefficients of the balanced chemical equation. Okay? It's how many moles of a product you can make with how many moles of a reactant. Okay? So the mole ratio is are the coefficients of the balanced chemical equation. Oh, did we not? We never balanced our acetylene reaction. That was delinquent. We should balance it. Now it's balanced. Where did I get my acetylene? I don't remember. Calcium carbide, by the way. The calcium carbide makes the acetylene. You can buy acetylene if they'll sell it to you at an air gas store where they sell welding supplies. But yeah, the calcium carbide, I don't remember where we bought it. I remember it was easy to buy. And I'm not going to tell you what we did with it, but you can probably use your imagination.
Did you make a bomb?
I'm not going to tell you what we did with it. Yeah, you can. Yeah, use the internet like everybody else. So basically, what a mole ratio means is if I have 1 molecule of calcium carbide and 2 molecules of water, I can produce 1 molecule of calcium hydroxide and 1 molecule of acetylene, because the ratio is 1 to 1, 1. Or if I want to use a mole, if I used a mole of calcium carbide with 2 moles of water, I would produce 1 mole of calcium hydroxide and 1 mole of acetylene gas. That's what the mole ratio is for. It says, I need this many moles or this many molecules to make this many molecules. If I burn 2 molecules of acetylene gas, I'm going to require 5 molecules of oxygen. I'm going to produce 4 moles of carbon dioxide, 4 molecules of carbon dioxide and 2 molecules of water. That's the mole ratio, 2, 5, 4, 2. Or if I wanted a million molecules, if I took 2 million molecules of acetylene, I'm going to need 5 million molecules of oxygen. I'm going to produce 4 million molecules of CO2, and I'm going to produce 2 million molecules of H2O. That's the mole ratio. So when someone says, what is the mole ratio? You say, oh, it's 2 molecules to 5 molecules producing 4 molecules and 2 molecules. That's the mole ratio. Does that make sense? I have a graphic for stupid people, but we'll move on. Okay, in and out, energy in and out. I have used this word before, and you've probably heard it in previous classes. The word is exothermic. What does exothermic mean? Austin?
It's where like the reaction produces heat and it gives off energy.
Exactly. An exothermic process is one that releases heat energy. So an exothermic process is one that releases heat energy. We think exit energy. Energy is like, I'm out of here, out of the system. And it releases energy. This was funnier 10 years ago.
Like when I was a kid, it seemed so innocent. Now it's just terrifying.
I know. Okay, so if exothermic is releasing energy, what do we call it when energy goes into a system? Endothermic. Excellent. Endothermic means it's absorbing energy. It requires energy to go on.
Does it absorb heat energy or just?
Heat energy, yes, heat energy. We'll talk about different types of energy in the spring, but yeah, it releases heat energy. We will. They're pretty rare, but we will do some in the spring when we do thermodynamics. So here's the thing about exothermic processes. I've got a lot of stuff up here that will react exothermically. I've got some matches. I've got some methanol. I've got some ethanol. I have some isopropanol. 70% isopropanol. I have gallons of this stuff. What better way to get rid of it than to light it on fire, right? Yeah. So my little pool of isopropanol, it's right there. And isopropanol reacting with oxygen is an exothermic process. Just like striking a match is an exothermic process. So why aren't they going?
Because it needs energy to get started.
Exactly. It needs a little bit of energy to get going. A little bit of friction energy and the match goes. A little bit of heat energy and the alcohol goes. Okay? So even systems that are exothermic require a little bit of energy. And that little bit of energy they need is to get over the energy barrier. We call that little bit of energy the activation energy, and the thing it needs to get over is the energy barrier. Anybody bring any marshmallows? Woo, woo, woo. Yeah. It's actually a very, very clean flame. Much cleaner than burning wood. Burning wood produces lots.
What you should have done is you should have brought a pan and some eggs and cooked them.
That would take a lot more alcohol. Yeah.
Are we able to buy this in stores?
Isopropanol?
Yeah.
Yeah, it's rubbing alcohol.
Oh.
You buy it at Walmart next to the hydrogen peroxide.
I'm going to buy a bunch of that stuff.
Fair enough.
Is it okay for
Just pour it all over your floor, light it on fire.
No, I'm gonna make Molotovs.
Me too. Who needs a fire?
Yeah, that'll be. I'm sure YouTube's going to enjoy putting that online.
Are you gonna get demonetized?
Oh, I'm private, so I can't be monetized. Although if you guys subscribe to my channel, if everybody subscribed to my channel this year, then I could actually give it a custom name. I'll even let you vote on the name.
Wow.
But right now I got like 35 subscribers. I need over 100. That's my point. I don't have a channel name. You have to search for like Chris Byers stoichiometry or Chris Byers reaction chemical reactions. Then you have to go to the channel and subscribe. And when I get enough subscribers.
On Google Classroom.
Callie's got a really good question. She says, why don't I link a video on Google Classroom?
No.
What do you mean?
Okay.
Somebody doesn't know how it's happening.
Okay, any questions? Question, America. The energy barrier is the... Oh, I want to tell you what it actually is, because we're going to learn that in the spring. Basically, you have to have enough energy so the molecules collide properly. And that energy barrier basically gives the molecules enough energy to collide properly. It's a little more complicated than that, but it'll do for now.